There's so much happening in the early years of school that at times it's hard to make sense of it all. So here's my attempt to make sense of the progression of addition and subtraction. So, addition and subtraction begin in kindergarten when students begin to count. They begin to count objects and sets. They do this by counting forwards, and they also do it by counting backwards. A big thing to remember is when we're counting forwards or backwards that we include the number 0. And when we're counting backwards, let's not have them include blast off, because blast off isn't necessarily a number. As students work on counting, they begin to count sets. So here, a student will have 4 in one hand, 3 in another hand, and they're not able to put those two sets together. There'll always be a set of 4 and a set of 3. Then as students move from counting sets to joining sets, they're able to combine the 4 and 3. So 4 and 3 more is 7, or 4 plus 3 is 7. As students begin to work on this idea of joining sets, we introduce 5 frames. And to be honest, I don't know if they get enough play in the early grades. So we'll have 4 and 3, and students begin to build an understanding of 5 frames and filling up a 5 frame. Students can see that 4 plus 3 is the same as 5 plus 2. And this understanding will build with students when they begin to use 10 frames later on. So in terms of subtracting, students can have 4 minus 3 and use a separate model, or they can also use a compare model. The big piece here is that a context should always drive the strategy that students are using. So as students are working on addition and subtraction, they're simultaneously working on this understanding of counting and collecting and grouping things in 10. So here 13 could be seen and should be seen as 10 and 3 more, or 10 plus 3. It's here that this whole idea of unitizing is introduced. It's massive, and we need to make sure that students don't leave kindergarten and first grade without this understanding conceptually. So as students dive into first grade, they begin to explore sums greater than 10. So what might that look like? Well, here, a student can take 9 plus 7, model it with a 10 frame, and because they've worked on this idea of unitizing, or they're beginning to, they know that it's most efficient to, say, fill up a 10 frame. So they take 1 from the 7, give it to the 9 to make a 10, and they're left with 6. Here, students are beginning to think flexibly about numbers, and the same understanding applies to double-digit numbers. The big piece here is that students, as long as they're using concrete models, they're also drawing representations. So what did we do? We want to make a 10. So we're going to take our 1s and bundle them up to make another 10. Decompose the 8 into a 3 and a 5, give 3 to the 37 to make 40, and have 5 more. So what does this look like with subtraction in first grade? Well, in first grade, students are only subtracting multiples of 10. And here, 37 minus 20, they can see if they remove 2 10s, they're left with 17. So what happens in second grade? How does this build on what they've learned in first grade? Well, they might use two-digit numbers. And here is where we begin to introduce base 10 blocks because of that whole idea of unitizing that students are still developing in kindergarten and first. Again, just like before, we'll draw a representation for our model. We'll create another bundle of 10. And here's how students can begin to move from the concrete to the representation to the abstract. Now, it might not be efficient, or students might see that it's not efficient to write it out on the side all the time. So, to become more efficient, they can begin to use this understanding of partial sums and find a shortcut. 8 plus 3 is 11, 40 plus 30 is 70, and this understanding of partial sums, well, it leads brilliantly into their understanding that they begin to develop with partial products in fourth grade. So that works for addition, but does it work for subtraction? Well, we want to try and use models that continue to work the same and consistently throughout math. We don't want them to expire. So here we want to have 83, and we'll go back to that separating model. We want to put 29 inside there. Well, we need 6 more. So This is a really big understanding for students where they make that fair trade and that idea of unitizing. So now we can take the 6 from the 10 and we're left with 4. So how can we move again from the concrete to the representation to the abstract? Again, everything that we're doing here and all the work that we're doing, we're not undermining place value. And what's great is that this model, this understanding that we're building, well, it also applies to larger numbers as well. Now we can use place value mats, we can use just open sheets of paper such as this, but anyway, students are still acting out that fair trade and they're making sense, the regrouping of numbers. So what does this look like as we begin to write it as an algorithm? We'll regroup the 20 into a 10 in another group. It's all about students seeing the math conceptually, and we're not undermining place value. So as students dive into 3rd and 4th grade, they have 2 years to begin to formalize this understanding of subtraction and addition with regrouping and unitizing. But the big thing is that it's built through conceptual understanding. The standard algorithm isn't an expectation until the end of 4th grade, right before students dive into decimals with 5th grade. And you know what? In 3rd and 4th grade, if students need to use expanded form to make sense of what they're doing, let them do it. It's all about the conceptual understanding and allowing students to visualize the math. So there's lots happening. As we've said before, let's take our time. The turtle won the race. Love to continue the conversation on Twitter or hit me up on my blog. Thanks for watching.